Welcome to Safecracking for Everyone. A little bit about myself. Who am I? My name is Jared Digert. I'm a lock sport enthusiast, gamer, rock climber, game developer, and I've been picking locks and cracking safes for about a decade now. So this talk is going to cover how Group 2 safe locks work, and mechanical combination safe locks are divided into two groups. There's Group 2s, which is your basic safe lock, no anti-manipulation features in them, also the most common type, and then there's Group 1s, which are more complicated and include various different measures to keep people from figuring out the combination. Now, whether you buy a $500 safe or a $5,000 safe, if it comes with a mechanical safe lock, it will most likely be a Group 2 safe lock. Very rarely are there Group 1 safe locks that come by default on a safe. Usually you have to pay hundreds of dollars extra for the lock, even more to get it installed, and it is not very common at all. So I'll be covering these Group 2 safe locks in this talk. I'll cover the flaws in this design and how to exploit them, along with specific techniques that is used to crack the combination. And at the end, I'll cover some slight differences between various Group 2 safe locks, since not all manufacturers create them the same way. First thing is knowing the parts of the lock. So this is the back of a lock with the back cover removed, and you can see that there is a silver lever here. Now the end of this lever has a protrusion, and this protrusion is called the nose. This nose is resting on a brass wheel. The brass wheel is called a drive cam. And this drive cam, you can see, has a cutout in it. This space, this empty space in the drive cam, is called the contact area. You can see where the cutout starts on either end, and those are the contact points. So the cutout is the contact area, and each end of the cutout where it starts is the contact points. And this drive cam is controlled directly by the dial. So there's a metal rod you can see in the middle, and that connects it directly to the dial. It's locked in place with this key. So whenever you turn the dial, the drive cam moves at the same time with the dial. Behind the drive cam, you can see a larger silver wheel. There's 3 of these wheels generally in each lock. Sometimes there could be 4, but most oftentimes it's 3. Now this wheel that we see here is called wheel 3. It's the 3rd wheel. It's closest to the drive cam, and when you're in front of the lock, it would be furthest away from you. And the other 2 wheels are behind it. Now, each of these wheels are exactly the same. There is a cutout in each of these wheels called a gate. Now, these gates are part of when you dial the combination. The gates all line up, and there is a metal bar behind this lever, and it lines up all of these gates under the metal bar when you dial the correct combination. So that when you turn the dial and the drive cam, so the contact area is under the nose, everything can fall down and fit nice and easily. So here, you would just continue turning the dial, and that would pull in this lever, and that retracts a bolt. The lever is attached to the bolt, and that pulls it in so that you can turn the handle and open the safe. The handle of a safe just pulls in the outermost bolts around the edge of the door so that you can open it, but the lock itself only locks the handle. So that's basically how safes operate. Is the locking mechanism locks the handle, and the handle is what pulls in the bolts from the outer edge of the door. Now, to demonstrate that, I have a lock here, and if we look at the back, you can see the drive cam. Whenever I spin the dial, the drive cam moves with the dial. So if I were to dial in the combination, that would involve putting the gate of the first wheel under the fence, and then I would put the gate of the second wheel under the fence as well. I messed that up, but I will just fix it. And then I put the gate of the 3rd wheel under the fence. I simply turn the drive cam, so everything can fall in, and then that will retract this bolt when I continue turning. Now the way that it works is each of these wheels has a protrusion on one side, and that fits into a groove of the next wheel. Now this protrusion will ride in this groove as the wheel spins until it hits this metal piece of the next wheel, at which point this next wheel will start to spin along with the previous wheel. And this wheel also has a protrusion which rides in a groove of the wheel next to it, and then after a whole rotation it will hit this metal bit, and then the next wheel will start to spin along with the rest of the wheels, essentially picking up each wheel after each rotation. So the drive cam has that sort of protrusion as well. So right now everything is spinning together, but if I were to spin the other way, you can see it is only the drive cam spinning until I make one full rotation, and then this third wheel, the wheel closest to the drive cam, starts spinning with it. So the third wheel gets picked up first, and then after another full rotation, you can see that the second wheel starts to get picked up as well, and it is spinning along with it. After another rotation, then this third wheel, or this first wheel, gets picked up as well. And the wheels are named this way because the first wheel corresponds to the first number in the combination. Since it is the last to get picked up, then it is set first. So then you can freely mess about with the other two wheels without upsetting the position of that first one. So the third wheel gets picked up first, corresponding to the third number in the combination, then the second wheel, and then the first wheel. Now the standard opening procedure for a lock is to spin 4 times with left rotation to the first number, which means you pass the first number 3 times and you stop on the 4th. Then you reverse directions, because if you were to keep going, it would mess up the position of the first wheel. So you reverse directions, spin 3 times with right rotation, so now we're turning counterclockwise. Now we're turning, clockwise to the second number. And then you do that 3 times. So you pass the second number twice, stop on the third time. And then twice with counterclockwise rotation, so we're reversing rotation again to the final number. We pass it once, and then we stop on the second time. Then we turn right until the bolt is retracted. Now the reason for this is because you have to spin 3 times to ensure all the wheels are picked up. You don't know the state of this wheel pack when you approach the lock. So it could be someone spun it to the right all the way before you approached it. So you want to make sure you spin 1 full rotation, will pick up that third wheel. 2 full rotations picks up the second wheel. And then 3 full rotations ensures that that first wheel gets picked up. So we just passed the first number in the combination 3 times. So now we have to go to it and stop on the 4th time. We reverse directions because otherwise it would mess up the position of that first wheel. So we do 1 full rotation, pick up the third wheel. 2 full rotations, now we pick up the second wheel. And so we pass the second number twice, and we stop on the third time. And I overshot it again. Reverse directions, 1 full rotation picks up the third wheel, and then we stop on the second time. And then we can turn right till everything drops in and the bolt retracts. Here's a really bad drawing. I mislabeled this. This is wheel 2 in the middle. So the dial will turn the drive cam until this protrusion picks up wheel 3, and then after rotating for some time, wheel 3 will pick up wheel 2, and then wheel 2 after rotating will pick up wheel 1, and so then they'll all start spinning together. There's a lot of vulnerabilities in this design. So you can see here when none of the numbers are dialed in correctly, and then we turn the drive cam, we turn the dial so that the contact area is under the nose. That allows the fence to drop down onto the wheel pack, essentially testing it for the correct combination. But the thing is, these wheels, they're not perfectly circular, and they're not the same size as each other. Some will be bigger, some will be smaller, and some will have bumps and dips, and that's because of manufacturing tolerances. It's basically impossible to get rid of these imperfections. What this means is, since one of these wheels is bigger, the fence is not going to be resting on all of the wheels at the same time. You can see here, between wheel 3 and the fence, there's actually a bit of space. It's not touching. Wheel 2 here, you can see, is larger than wheel 3 and wheel 1. This fence is only touching wheel 2. Now, we can also see that this contact area, where the contact points are on either end, it is sloped to go down. And that means there is less wiggle room, so to speak, between the sides of the contact area the further down you go. So let's assume that wheel 2, let's pretend that the wheel 2 combination is dialed, that the gate for wheel 2 is now under this fence. What would happen? Well, this fence would not rest on wheel 2 anymore. It would drop down ever so slightly and rest on wheel 3. That means this nose would be lower in the contact area, and there's less wiggle room between the contact points. The really cool thing about this is you can feel this on the dial. So if I were to reset this, you can see that the nose drops into the contact area when it's over the contact area, and that allows the fence to rest onto the wheel pack. So if the largest wheel has the gate under the fence, this nose is lower, and so this wiggle room, you can feel this bit of resistance. You can feel each contact point from the dial. That wiggle room would be less. So the contact points, about 96 for the left one. We name it from viewing the dial, So the more sloped side here on the left in this view is the right contact point, because from the front of the safe, that's the right. Oops. So this left contact point is about 96, and the right contact point is about 3. But if perhaps 2 of the wheels were dialed with the gate under the fence, we might feel this at 98 and 2, thus the closer contact points, less wiggle room. So that is a major vulnerability and the main thing we use in order to determine the combination. So we can know through this when the gate of the largest wheel is under the fence, simply because there will be less wiggle room between the contact points. So the first step is finding a number in the combination with this information that we now have. So what we do is we have to take a series of test combinations every 2 or 2.5 numbers. The tolerances of these locks sometimes allow you to go every 2.5, but generally it is safer just to go every 2 numbers. And there are 2 contact points, the left and the right, but as shown earlier, the right contact point is more sloped. So there will be a greater change in the amount of wiggle room from the right contact point. The left will move in a little bit, but not as much as the right. So we really only need to know what the right contact point is at any given time. And you can graph this as well. So if I get my graph paper right here, you can see this is a basic layout of a graph. So along the top we have 0 to 100, and then here I put the closest whole number to the left contact point, one above and one below. Same thing with the right contact point, one above and one below. And as I mentioned, you don't really need the left contact point, but it is good supporting evidence if the right contact point is not really giving clear readings, which we will cover later. So you can graph both of the contact points like this. So first thing is you want to turn the dial left 3 times to pick up all of the wheels, and then stop on the first reading, so we can just say we're going to try 0. Now, the reason we spin left and we pick up all the wheels with left rotation is because the combination is found, or is dialed, with left, right, and then left rotation. So left to the first number, right to the second, and then left to the third. So if we find a number, it's kind of random. We don't really know which wheel is going to be at first, right? We just know one of the wheels is larger than the rest, and we want to figure out when that wheel has a gate under the fence. So it's just, you know, statistics that it's going to be more likely the first and the third rather than the second. Also, because of the way the locks are designed, wheel 3 would generally be larger, or will be the wheel that makes contact with the fence first, so that's more evidence to start with, more reason to start with left rotation first. So what we do is we spin the dial, pick up all the wheels with left rotation, and then we stop at our first test combination. So in this case that would be 0, 0, 0. So we stop at 0. And then what we do is we want to reverse directions, because if we were to keep going that would mess up the position of the wheels. So we reverse directions until we get within the contact area. So remember, our contact points are 96 and 3, so we want to spin left until we're within that. We don't want to pass 0, because remember, after one full rotation we pick up the third wheel. So we just want to go between 0 and 3, and then you just spin. I accidentally passed it, but we'll ignore that for now. You want to gently spin the dial left until you hit the contact point. And you don't want to ride up on it. You don't want the nose to ride up onto the drive cam. You just want to go lightly and stop when you feel that bit of resistance, and then you can record that. So on the graph at 0 down to 3, let's say we feel at 2 7/8. Then you can mark that from here, 2 7/8 for 0. Okay, so that can be about here. And that is also really important, is you want to be able to differentiate between 1/8 of an increment. And that's really hard to show on camera here for this, because it's not really precise, and also the resolution of the camera. But you want to be able to look at the dial and know whether it is showing like a 2 7/8 or a 3, or a 35 1/8 and a 35 2/8. And you want to be able to accurately record that, because what we're looking for is a change of a 1/4 increment. So we want to make sure that our measurements are taken with a precision of 1/8 of an increment, just to be safe. So, whoops. Okay, so we're going to pretend that we did this for the entire I guess all the numbers of the safe. So if I were just to fill it in just with some random points, and I'm just putting a generic reading here. And as stated earlier, you can record the left contact point here as well. It's just that it's not going to be as much of a variation. So here, essentially what we're doing is we are taking the overall shape of all the wheels, of the wheel pack, and we're just laying it out in a line. So if this were to be cut into a strip of paper and put into a circle, this is what the wheel pack would look like on a very fine scale. Because remember, they're not perfectly circular, so on a very fine scale, there's a lot of bumps and ridges and whatnot. Now, if you remember, I'll show the picture again of the close-up. When the gate of the largest wheel is under the fence, that causes a drop, right? There's less wiggle room. That right contact point moves in, so it gets lower. The left contact point would get higher. So that's essentially what we're looking for on the graph. We're looking for where the right contact point drops down for maybe a number or two and then goes back up, because the gate would be under the fence and then you would go past it and then would not be under the fence anymore. So it would drop down and go up. So essentially you want to look for the shape of a gate in this reading. Now you can see there's a drop here, but it goes on for a little while before going up, so that's probably not it. That'd be really wide for a gate. But here you can see it drops down for a quarter of an increment for 2 readings and then drops back up. The thing about these safes is, these safe locks, is you don't have to be precise in dialing. That is also why we go every 2 numbers. You go from 0, 2, and then 4, every line here on this graph. So if the combination is 16, 28, 40, you can dial 17 or maybe 18, 28, 40, and it would still open. So you want to look for the shape of the gate in the graph, and that will tell you one of the middle of that gate will tell you one of the numbers in the combination. Now we're going to assume that the number we found is 40. So at this point we know that the largest wheel in the lock has a combination of 40 associated with it. Okay, but we don't know which wheel yet. We just know that there's one of the wheels in the lock is larger than the others, and the point at which the contact area goes closer together and then further apart centers around 40. So we do something called the high-low test. We put 10 numbers lower on the first wheel, and then we put the other 2 wheels on the correct number. So we're pretending we found 40 as the correct number. So we will throw the first wheel off by 10 numbers lower. Now, we found 40 with left rotation. So whenever we put one of the wheels on 40, it always has to be with left rotation. So the first number, we will use right rotation to 30. We pick up the wheels, all the wheels, so 4 rotations to 30 with right rotation, and then we spin left 3 times to 40. So that would put the second and third wheel on 40. And we will measure the contact area here. And here it is important to take both left and right contact points, and then what you want to do is figure out the space between them. So if it is at 96 and 3, that is a 7 number difference. So we would write down 7, and we would record that down. And then we do the same with the second wheel. We put the first number on the correct number, so left to 40, left 4 times to 40, and then we go right 3 times to 30, putting the second wheel, throwing it off by 10 lower to the wrong number, and then left to 40 on the third wheel. Record the space between the contact points, how many numbers there are, and then write that down. Now we do that again for the third wheel. Left rotation 4 times to 40, and right twice to 30. That ensures that only one number is off. The other 2 wheels are on the correct number. And then you can repeat with 50 as well instead of 30, so that would be the high test. Now, the test combination with the widest contact area is the one that 40 belongs to. So, for instance, we did 3 test combinations here for this low test. If for this last sequence that we dialed, 40, 40, 30, if that has the contact area with the most space between it, now normally before we were looking for closer contact points, but here we're looking for furthest apart. And the reason for that is because we have the correct number on the wheel, on 2 of the wheels, and the wrong one on 1 of the wheels. So if the wrong one is on, let's say here, let's say the 3rd wheel has 40. So if we're intentionally putting on the wrong number, it's going to be a wider contact point. But see, in these two, it's got the correct number, so it'll be closer. So this allows us to figure out which wheel that 40 belongs to, simply by putting the correct number on each wheel twice, and then having it off on one of these. So if this wheel, if the wheel 3 has 30, and it's wider here than the other 2 tests, then we can successfully conclude that 40 belongs to the 3rd wheel, the 3rd number in the combination. And then you can, repeat with 50 just to really be sure that your readings are correct. So we're going to assume that 40 here is the 3rd number in the combination. And then, check your rotation. Anytime you dial to a correct number, you want to make sure you always use the correct rotation. Now we found one of the numbers in the combination, and we know it's the 3rd wheel. So, in order to find the other numbers, we essentially just repeat the same step with this new information added in. So we run the other 2 wheels through every 2 increments, but we have the 3rd wheel on 40 whenever we read the contact point. So the way that this is done is, we know that the 3rd wheel, right, the first wheel that gets picked up, that means we have to set it last. That is with left rotation to 40. So what we want to do is we want to pick up all the wheels with right rotation now, and then we'll say let's start at 0, and then we spin left for 1 rotation, so that picks up just the 3rd wheel, and we stop on 40. So now we have left rotation on 40. Now going to 0 isn't going to affect any of the wheels now, remember, because we have to pick up the 3rd wheel in order to affect the rest. So we can safely move around here without fear of disturbing the other wheels. So we can read the contact point again. Going from inside the contact area, we can read the right contact point and then graph it. So we would just do this graph, and at the top we can maybe just write wheel 3 left 40, just so we know that we're doing this graph with wheel 3 on 40 with left rotation. And then what you can do now is you turn right until you reach 40. Now that picks up the 3rd wheel. Go to 0 where the other 2 wheels are resting together, and that picks up wheels 2 and wheels 1 at the same time. Because remember, we had everything picked up together. We only messed up wheel 3 in order to put it on 40 by itself. You can turn 2 numbers over, spin left again 1 full rotation to 40, go to the contact area, and report it down again. And we just go do that the whole way around. So here we can repeat the same high-low exercise. So we're going to pretend we found a drop in the graph and then a rise back up at centered around 80. So we found 80 with right rotation now. So what we're going to do here is a low test. Okay, so we're going to start with here wheel 2, and we're going to throw it off by 10 onto 70. So wheel 1, we put it on the correct number, 80 with right rotation. So that means we spin right, picking up all the wheels, stopping on 80. Then we spin left, picking up wheels 3 and 2, so we go 3 times to 70. And then here's where it gets interesting. We need to go to 40 now with left rotation because we found 40 as the correct number with left rotation for wheel 3. But if we were to continue past 70 left into 40, it would mess up wheel 2. So there's actually a clever way to fix this. So we spin right, picking up all the wheels, and then we stop on 80, which is what we found to be one of the other numbers. We can spin left, 1 rotation, picking up wheel 3, another rotation, picking up wheel 2, and we want to put wheel 2 with left rotation on 70. So that is 10 lower. And then we want to go to 40 now for the third wheel. But if we were to keep going, it would mess up wheel 2 on 70. So what we do is we can reverse directions here, pick up wheel 3 from 70, go to 40, but remember this is not the correct rotation. We're turning right. We need to be turning left. So we just go past it, let's say to 30, and then we can go left, picking up at 30, setting wheel 3 on 40. At which point we take our contact point readings for our high-low test. And then again, you would write down the number of increments, you know, the space between each of the contact points. And then do that with the first wheel. We throw the first wheel off by 10. So we go left to 70 for the first wheel, picking up all the wheels, and then right 3 times to 80 and the left to 40. So we write down the numbers. Again, we look at what is the widest contact area, and that will give us where our second number lies, like which wheel it belongs to. And usually locks will read this way. It will read third wheel first, and then the second wheel, and then the first. But sometimes it can go other ways. But following this method, it doesn't really matter which wheel reads first. As long as you know how to dial in these numbers, then you can still do it just fine no matter which wheel reads first. And then here we have 2 of the numbers in combination. So let's pretend that 80 belongs to wheel 2. So it's a question mark for wheel 1. We know 80 is right rotation to wheel 2, and then 40 is left rotation to wheel 3. And the last wheel, you can graph it, but generally you just brute force it. You would just try 2 80 40 or 0 80 40, 2 80 40, 4 80 40 until it opens. When you're starting out, it is actually a good idea to graph that last wheel as well, just in case you messed up on the first 2 and you did not find the correct number. It is useful to have that extra information. Now there's different group 2 locks. The one I am using here that I have shown is what is called a Sargent and Greenleaf, an SNG 6730. There's 2 major variations, a 6730 and 6741. They operate the same way, work the same. You cannot tell by looking at it which one it is. It's just that the 6730 has slightly tighter manufacturing tolerances, which is why I recommend going every 2 increments on your graph rather than every 2.5. But if you know you have a 6741, if it is labeled a 6741, then you can get away with going every 2.5 increments, because those tolerances in the manufacturing are not as tight, and you will be able to find the correct number by going every 2.5 increments. Now, another popular brand is Lagarde, the Lagarde 3330. They have slightly oval wheels, and the reason for that is because of the way that inside the wheels work. There's a certain mechanism that allows you to change the combination, and that puts pressure on the wheels in certain ways, and that just makes it slightly more oval shaped, which means the wheels can essentially mask the gates on other wheels. Maybe none of the wheels are, you know, bigger than the others, but they can be aligned that when they're all picked up and they're all moving together, the oval shape covers, essentially becomes the biggest part of the wheel pack in that location, and that gate is never going to allow the fence to drop lower, because one of the other wheels will be larger in that area. And so it can be rather difficult to work with a Lagarde 3330. So I do not recommend starting out with that. There is also a Diebold, which is a lock with a drive cam where instead of having one side that's more slanted, it will be a U-shape, more uniform U-shape. And so in the case of a Diebold Group 2, you want to take both contact points into account, since there will be less variation in each. You want to take both into account and look at the left going up and the right contact point going down. Whoops. Now, some final tips is you want to be really precise in dialing. You want to not just read it in 1/8 of an increment, but you want to dial to 1/8 of an increment. You want to make sure you're not accidentally dialing 16 and 1/8 or 16 and 1/4 because you're going every 2 increments. So maybe the combination is 15. You don't want to go 16 and 1/8 and have it not open, but maybe on 16 you can detect it. You can detect that it's the correct number, but not 16 and 1/8. You want to make sure you're reading the dial from the same angle each time. So if you're looking at the safe lock, you want to make sure you are reading from the same angle. Let's say you're reading it from this angle this time. You don't want to look at it like this, as that will change where you think that contact point is. So you want to make sure you're really consistent, especially also with the amount of force that you use. You want to make sure it's the lightest possible, and you want to make sure it is the same each time. So you want to be really consistent in everything you do. You can also try it with a known combination. You can, let's say you know the combination is 20, 40, 60. Well, you can test at 20, 40, and 60. You don't have to graph the entirety of the dial. So just to be able to detect how the contact point feels when one of the gates is under the fence and how it feels when it's not, you can graph from, let's say, 10 to 30, and then 10 above and 10 below each of the numbers, 20, 40, and 60, so that you can tell how the graph is supposed to look. And that is a very, very useful practice to do. You can also remove the back cover of the lock so that you know exactly what's happening, and you can really correlate what you're feeling with what is happening inside the lock. And then, if all else fails, you can buy my book. Well, not really. I put it online for free, so it is on Amazon, but I don't recommend it unless you really want a hard copy. There's a PDF I have uploaded at this link down here, and you can download it and basically just do whatever you want with it. I don't care. Now, on YouTube, I have a video series that follows the book. It's similar to this talk, but it's a lot more in-depth. So it covers different sections that I have covered here in this talk, but with much greater detail, and I also cover additional more advanced techniques in order to figure out the combination faster and with greater precision. There's online forums, such as this link at the bottom here points to keypicking.com, and they are very welcoming to newcomers as long as you are able to show that you are not trying to use this knowledge for criminal activities and you are interested in this as a hobby. I mean, people are very welcoming. eBay, you can buy locks on eBay. I highly recommend SNG 6730 or 6741. You can also just search up SNG 6700 series. And just practice. I mean, practice is the best way to learn. I mean, you can read and watch all the content on Safecracking and understand everything that's happening, but you cannot develop the touch for feeling the contact point. You don't develop the sight for reading the contact point unless you actually practice. And I also just remembered I forgot to mention this picture here. So in order to read the contact points and dial it more accurately, you can take a piece of paper or maybe a needle or anything and tape it onto the dial and the dial ring just to be able to more precisely pinpoint what is on the dial. And that is the end of this presentation.
Good day, lock manipulator.
Good day.
So known as Jared. Thanks for your talk. Just to get things started, I got a couple of questions for you, and hopefully it'll give other folks enough time to ask a couple of their own. So number one, how did you get into safecracking?
So I got into safecracking from lockpicking, which I originally got into as a kid from the need to bypass a lock to the room my parents kept all my toys in when I was little. And so basically I went from lockpicking uh to finding a forum about it, and then meeting people on there that started doing safecracking, and then got into safecracking that way.
Nice. So when you started, did you buy or build your own equipment?
Yeah, so when I started, it's actually kind of funny because I didn't have like my book or my talks or really condensed information. I had to kind of gather it from a bunch of different sources. So I didn't know really like what lock to buy to practice with or like how to buy it and all that stuff. So I actually started with my dad's safe. And so I just used the lock on my dad's safe when I started.
Nice. Now, having done this before, knowing that there's a big learning curve and you've broken down the process really well, do you have any other tips for anybody starting out?
Yeah, so really the thing I cannot stress enough is just to have patience. I mean, things are gonna go wrong. You're going to do something right and expect a certain result, but it could just not be there. It could just be a totally different result than you're expecting. And it could be through no fault of your own. I mean, every lock is different, and you have to approach every situation individually. So you could do everything right, but you just got a little unlucky that time. So it's really about patience and making sure that you are doing the best that you can, like reading contact points accurately and dialing.
All right, so set my expectations. How much practice am I looking at before I start to get the feel?
Oh, so everyone's different. And it does also depend on the lock you start with as well, I guess. I mean, if you're starting with some cheap Chinese clone with really, really bad manufacturing tolerances, it'll be a little easier. Um, but I would say generally, on average, a week. Some people get it within a few days. Some people get it after a month. But usually, I'd say a week is the median.
A little bit more work than lock picking.
Yeah, for sure. And it depends on how much time you put in. Like if you do a whole week of study, that's about how long it should.
Do we have any questions from anybody else? Put it in the chat. Jared's here to answer for you.
Yeah, a funny story I guess about some safe cracking that I did is I and this is recent as well, but I recently got a girlfriend and went to meet her parents, and turns out that they actually have a locked safe in their house that they want to use, but they don't know the combination. So within the first 30 minutes of meeting her parents for the first time, I cracked their safe, and that's how I introduced myself.
I was going to say that's a pretty good way to make friends. And what's next on your safe cracking path?
So I would like to get started in learning hardware, and building a tool to automatically crack a safe. So there's tools that exist, auto dialers, that just brute force it, but it's not equipped with the sensors or software to actually go through the process of cracking a safe. So I want to develop a tool, like I would love it to be open source hardware and software that can actually get feedback from the dial, and I can program in my method of cracking a safe to, into this device. That would be the next step.
Put a bunch of people out of work.
Um, I don't know about that. There's a lot of different safes, and most safe technicians drill anyways. Um, because it could be like old safes, for instance. The process for cracking them is different, or if it's a high security safe, process for cracking those is different. or it could be a broken safe. I mean, there's a lot of different things. So I mean, safe technicians are still pretty safe, as this would be a very narrow like tool. The target is very, very small.
Yeah, that's cool. Have you worked on the electronic ones at all?
No, not much. I have learned a little bit about the electronic safe locks, but I mean, it requires different equipment to crack, I guess you could say. But yeah, it's about like measuring voltages across wires and like that.
Cool. I am not seeing any more questions off of the chats. So I'm going to say thank you very much, both for your talk as well as spending a couple minutes with us.
All right, thank
Have a
you for
great
the
day.
opportunity.